Hello, I want to go over a couple problems from the lab that's due tonight. So this is lab number 3, Taylor Series Application Lab and Remainders. So if I'm looking at 5a as an example, how do we find the value of an infinite sum? Generally, this is very difficult. I have this down written over here. But notice if I look at this pattern, pi minus pi cubed over 3 factorial, and so on, we end up with this general form right here. And that odd factorials and the plus minus should be a clue that we were looking at a sine Taylor series expansion. And the only difference being instead of x, we're throwing in pi. So it's sine of pi, which is 0. So we got that the series converges to 0. So I really want to go over in a little more detail, how do we get an estimate? So for part 6, determine the minimum number of terms to be summed to obtain an approximation that's within 1 over 100 of the exact value of the series, which is pretty nice. A lot of times we don't know the exact value, but in this case we do. So I'm going to use the alternating series estimation theorem. It says the remainder is going to be less than or equal to the n plus 1 term. So if we think about that here, the n plus 1 term in this case is going to be, ignoring the minus 1 to the n, that's going to be pi to the 2n plus 3, because we throw in an n plus 1 into n, and in the denominator we're going to take 2n plus 3 factorial. So we want to figure out what n in this these terms gets me less than, I'll say less than or equal to 10 to the minus 2, which is of course 0.01. All right, so if we didn't have this factorial, we could solve this algebraically with the factorial and a variable in the exponent. This is actually very difficult to solve algebraically. So I'm going to set up a spreadsheet. I'm going to look at a spreadsheet and look at when do these terms, the non-alternating part of the terms, get to be less than 0.1. All right, so I have a spreadsheet. We start at 1 or 0 for this series, and I'm going to look at these terms bn. So it's going to be equal, and I want to enter this this formula in. So pi to the 2n plus 3. So in Excel or Google Sheet, to do pi, it's pi and then open close parentheses. So it's pi is a 0 argument function in Excel or Google Sheets. And I want to raise that to 2 times n plus 3. And then we're going to divide that whole thing by 2n plus 3 factorial. So in Excel or Google Sheets, the factorial command is FACT for factorial. And then I want to take the factorial of 2 times n plus 3. And if I double click here, and we could get more terms if we need to. But notice right here, the fourth term is 0.007. That is going to be less than 0.01. So put a note right here. Since the fourth term is less than 0.01, we need at least 4 terms to be within 0.01. All right, and that is it. Okay, so I want to do just double check just to make sure this actually makes sense. Is 4 terms enough to be within 0.01 of 0? So if you go more than 4 terms, you're going to be safe. It'll be even more accurate, but we need at least 4 terms. So I want to go right here and take the terms. Instead of bn, I'm going to call this an. So I want to change this value. You see up here, I'm going to, I'll just rewrite this all together. I'm going to throw in the minus 1 to the n, and then times pi to the, if we do the regular terms, it'd be 2 times n plus 1. And then divide that whole thing times by the factorial of 2 times n plus 1. So this would be the n plus 1 term. This would be the actual n term. And if I go back here, double click, you can see we have this increases once and then decreases to the absolute value. So these would be just the terms of the sequence. If I want to get the series, and just start adding these values up. So I'm going to take previous value plus the new value. And if I click and drag this down, at each point this is going to add this previous term to the series, then add the new term. So this gives us the series. And notice right here, if I go to those 4 terms, I get 0.006925. And once I change the next one, after 4 terms, notice the first 2 decimals do not change. Right? This is 0.00. So 4 terms is sufficient to be within 10 to the minus 2 of the actual value.